Hello everyone, welcome back to another LeetCode problem. Today we're going to be doing problem 496, next greater element 1. And this isn't an easy problem technically, but we're going to focus on the optimal solution for this problem, so that one won't be so easy. That's more like a medium or maybe a little bit tougher. And so the problem is the next greater element of some element x in an array is the first greater integer element that is to the right of x in the same array. You're given two distinct integer arrays, nums1 and nums2, where nums1 is a subset of nums2. And you are trying to find, in each number of nums1, you're trying to find where that number is in nums2 and what's the first next greater element. So for number 4, we could see it's right here, and there is no next greater element because everything to the right is smaller. Then for number 1, it's over here, and the first next greater element would be 3. And for number 2, there's nothing to the right, so that's also invalid. And if there is no next greater element, we can output -1. So I think I would assume that for the easy solution, what would that be? So that's probably going to be something like the brute force. And so for a brute force, what's the most brute force we can do? Well, we can take, for every element in nums1, we can just find where is it in nums2. So we just say, for every number in here, loop through this. As soon as we find it, keep going to the right until we find a greater element. If we do find it, then put that in. And if we didn't find it, then return -1. And the problem is the time complexity of this is going to be n squared, because we're going to have to go through this array, and then we're going to have a nested loop with this array. And so it's asking, could you find a solution with big O of nums1 length plus big O of nums2 length? And so the solution is going to be a little bit trickier. It's asking us to not have a nested loop, and how would we do this in another way? And so another way to do this would be, let's just think about it for a second. So what we want to do is we want to find the index of each one of these numbers in this loop. Now ideally, instead of searching through the entire loop, we would want to be able to go to the number directly. So that would be the first thing we would want to do. So how would we do that? Like if we have this 4, we'd want to be like, okay, well, what's the index? Well, what we could do is we could have a dictionary. And so for each of the numbers in here, we can, so let's just say this is 1, 3, 4, 2. We can loop through all of these numbers, and we can just store. So we can store key equals number equals value, which is the index. And so it's also telling us that all of these numbers are unique, so we don't have to worry about having a value at multiple indices. That'll never happen. So we could go through this loop, and then we could just keep track of every number and every index, and then that way, when we call for something like 4, we could say, oh yeah, okay, well, we have the index of 4, so we can jump to it directly. So that solves one issue, where we just have to loop through this one time, and we store every index. Now the other issue is to get the greatest number, or the next greatest number, even if we know where this is, for example, this 4 is, well, what if we don't have a greatest number? Like, let's say we just have some huge list like this, and let's say this is, like 1,000 elements, and it just goes 1,000, 999, 998, 997, and so on. And so even if we know where we're at, like let's say we can jump here directly, well, to find the next greatest number, every time we get to a number, we're going to have to loop to the very end. So this would still be n squared. Like if we have a bunch of numbers here, we're going to have to loop to the very end. So how do we solve this issue? So this wouldn't be 998, but you get my point. This would be 997 and so on. And so a common problem you want to recognize is when you're trying to find the next greatest element or the first element, there's a couple problems on LeetCode like this. I think there's like daily temperatures and some other ones. So when you're trying to find the first element greater than the element we are looking at, what we're going to want to do is we're going to want to have a stack. And so let's demonstrate this. So let's say we have these numbers, 1, 3, 4, 2 again. So what we're going to do is we're going to want to have a stack. So we have a stack that's, let's just say it's empty. And we're going to go through all of these elements. And what we're going to do is if the stack is empty, we just push the element in. So let's say, and the way we're also going to figure out what index to, like let's say we have an element in here and then we find an element greater. Well, how do we know what was the index of the element that we were looking at? So we're going to want to store something like this, or we're going to want to store 1 and the index of 1, so that would be 0, and so on. So we would store 1, 0, 3, 1, 4, 2, and so on. And then once we find an element that's greater than it, we can always just go back to the index that we were at. So let's just walk through this for this example. So we're going to loop through this entire array, and we're going to put these numbers in the stack if it's empty, and if it's not, we're going to check, is this number that we're at greater than things that are in here? So let's see what that would look like. So our stack is empty, so our first iteration, we're just going to put in 1, 0 here. Now so we were at here, now we are here. So is 3 greater than, and our stack, the way we're going to do this is our stack should always be in decreasing order, because if it's increasing order, that means that the number to the right of this number, like if there's a 3 here, it's greater than the 1, so we can just pop the 1. So let's see what that would look like. So we can just have something like this, where when we're at our element, we can just say while current element is greater than stack minus 1, which is the last element in the stack. So in this case it is. So we're at 3, it's greater than 1. Okay, well now that we know that 3 is the next greatest element of 1, we don't really need this 1. So we're going to pop off this 1, and we're going to update this index to 3. So we're going to pop off this 1, and then the stack is empty now. So we're going to put in 3, and the index of 3 is 1. Okay, now we're at 4. We're going to do the same thing. We're going to check from the back of the stack, is 4 greater than the last element in the stack? Yes, it is. So we're going to pop it again. Then we're going to put 4 in the stack along with its index. And then our last element is 2. So we're going to say, okay, well, is 2 greater than 4? No, it's not. So if we can't pop anything from the stack, we're just going to append to the end of the stack. So 4, 2, and then this is going to be 2, and then the index of 2, which is 3. So you can see the stack that we end up with, our stack is always going to be decreasing, because anytime we have something bigger, we're going to be popping from the end. And there's another thing we need, by the way. So we have a nums1, we have a nums2, but we also need, we need something to keep of the next greater element for all of these values. So we can loop through this nums2, and we can actually do this in one's loop. So let's write this down. So loop through nums2, save every number and index in a dictionary. So that's this store key equals number value equals index. So we need to save every number, every index in a dictionary. Then we use our stack to update the next greatest elements. And we need to so this is what we need. We need to update these next greatest elements. So where are we going to store these? So what we're actually going to do is we're going to make a new array, and we're going to have it be the same length as nums2, and we're just going to initialize every element to -1. And the nice thing about this is, if we didn't update the next greatest element for some value, like for here, we never updated the next greatest element of 4, and we never updated the next greatest element of 2. If we never updated them, they're going to be default -1, so that'll take care of that. But we did update 1 to be 3, so index 0 is going to be 3, so this would be 3. And then we also updated index 1 to be 4. So this would be 4. And so these are the next greatest elements, and they're going to be at the exact same index as these. So like if we want to know what's the next greatest element of 1, we just say, okay, hey, where's 1 in our dictionary? It's at index 0. Okay, so the next greatest element of 1 is going to be at the same index because they're the same length. The next greatest element of 1 is going to be 3. And so for this output, let's say for 4, 1, 2, okay, we're going to say, okay, well, where's 4? 4 is at index 2. So at index 2, we're at -1. Then 1 is at index 0, so that's 3. And 2 is at index 3, so we're over here, which is -1. And that would be our output. So we do need to have one more. So we need to have a variable that's the dictionary of the locations of each of these numbers, so we don't have to loop through the entire array. And then we also have another variable for this next greatest element thing. And then at the end, we just loop through all of these numbers in nums1. We have some kind of res or output array, and we just append to that. And that shouldn't give us any more space complexity because we already have this next greater element array. Okay, so let's code that up. So the first thing we're going to need is we're going to need a dictionary of locations, let's say. Then we're also going to need this next greater element array. So next greatest greater element array is going to be like this. Okay, and we also need a stack. And usually for these problems, like I said, if we were doing the easy solution, it would be n squared complexity, and we wouldn't actually need any extra space. I mean, we could have a res output, but that's about it. But the problem is we have n squared time complexity, so usually you want to have some kind of trade-off where if the time complexity gets too big, ideally you want to have big O of n for both. So this is going to be a better solution. Okay, so let's code this up. So like I said, we need to loop through nums2, so range length nums2. And what we need to do is, for every element, we need to store its location. So then we also need to use our stack, as we said before. So when our stack is not empty and the element we're currently at is greater than the last one in the stack, so let's do that. So while stack and nums2 I is greater than stack minus 1. And so remember, our stack is going to have a tuple or a list of two values where the first value is the number and the second value is the index. So we need to check it with this. And so if this is the case, then we need to pop off the end of the stack because we found the next greater element for the value in the stack. So we can just say number index equals stack.pop. We actually don't even need this number now that we compared it, so this can just be this. And we just need to update this index with the next greater element here. So we can just say next greater index equals 2i. Okay, so this is going to keep happening until we either pop the whole stack or this number is no longer greater than the last element in the stack. And now after we do that, we need to append it to the stack. So stack.append. And then remember, we're appending the number and its index. Okay. And I think that's it for this part of the code. So we should be able to go through the stack. We should be able to go through this nums2 here. So now that we have, now what we did was we populated this next greater. We can even print it if we want. So if we just print next greater, let's see what that looks like. Just to make sure we did that correctly. Right, so it's 3, 4, minus 1, 1. So let's see. So the next greater for 1 is 3. The next greater for 3 is 4. The next greater for 4, there is none. And then the next greater for 2 is negative 1. So this is correct. So now all we need to do is we need to have some kind of output array. So let's just call that res. And then we just need to loop through every number in nums1 and find its next greater element in this next greater array. So how would we do that? We would just say for I in range length nums1. Then we would say res.append, and then we are appending next greater, and then we need to get the index. So remember, these next greater indexes match exactly with the nums2 indices, so we need to find where is this nums_i. So if we're at like 4, we need to say where is the location of 4. So this would be locations of the number we're currently at, which is nums1i. Then we can just output that. So let's see. Oh, okay, I was silly. Okay, let's try to submit that. Yeah, so you could see it's quite a bit more efficient than the average solution. So let's actually, and you can also see that, yeah, they even tell you this daily temperatures is going to be kind of similar to what we're doing here, which is, this is the one with a stack. So let's think of the time and space complexity for this. And I did actually find if you do the optimal solution to a lot of these easy problems, they become harder than a lot of medium problems. Okay, so let's see what we're doing here. So we are looping through nums2 one time, and then we're storing every single location in this dictionary. And the most values we can ever have in our stack is the length of nums2. So this whole loop right here is going to take, like, let's say this is n and this is m lengthwise. So n is the length of nums1, and so let's write that down real quick. N equals length of nums1, m equals length of nums2. This, we're looping through nums2 one time, and then here we're looping through nums1 one time. So our time complexity would be this solution right here. So it would be n plus m. Okay, so now let's think of the space. So what are we using? So we have this locations dictionary. This locations dictionary is going to have a value for every single key nums2. And then we also have a stack. And the most values we can possibly have in the stack is every number in nums2. Which means this would be m plus m, worst case. And then we also have this res that could also be the same, worst case scenario, it could be the same length as nums2. So it'd be m plus m plus m. And this is 3m, which just goes down to m. So that's our solution for the space. Okay, so that's it for this problem, and I'll see you in the next one.